Okay, let's have a crack at this one. So we're going to find the normal for the quadratic 3x squared minus 5x plus 4, where x is equal to 1. Okay, so what does that mean? It means that we have the quadratic, and somewhere along here, we have x equals 1. And if we drew the equation of the tangent, it would look like this. The equation of the normal is perpendicular to it, so it looks like that. And this is what we call the normal. We are looking for this equation. That's the objective. Okay. In order to do that, we actually need to come up with the gradient of the tangent first. Okay. Yes, Levi?
I was wondering, when would you use the normal? Like, how does that help you solve something when you know the normal?
Suppose that we're going to create an architectural bridge. Okay. And so you're going to build trussels or supports, things like that. So these would all be normals.
Okay, cool.
Okay. All right, so let's do it. Okay, we need to know the coordinate. Okay, so we know x is equal to 1, but we don't know the y value. So let's do that first. The function for when x equals 1 would be 3 times 1 squared minus 5 times 1 plus 4. 3, take away 5 is negative 2. Negative 2 plus 4 is 2. So our coordinate is 1, 2. Sure? All right. Now, what do we need next?
The derivative.
The derivative, because we want to know what the slopes are, right?
Yeah.
So the derivative would be 6x minus 5. Yeah. And what do we do next?
Now we put 1 as x to find the
we plug in
slope.
the 1 because we want to know what the slope is at that coordinate. Excellent. So plug in 1 into the derivative function, and we get 6 take away 5 is 1. And write yourself a little conclusion. So therefore, the gradient is 1 at this coordinate.
And then do we divide it, put the denominator, no, the numerator? Wait, which one's the bottom one on the fraction?
Denominator.
We put that as the denominator and then do it over 1.
Yeah, no, I know what you're trying to say.
Yeah.
So first of all, this slope, is this the slope of the tangent or is this the slope of the normal?
Slope of the tangent.
It's the slope of the tangent. So put a subscript t in there because we are about to calculate the slope of the normal. Now, if the slope of the tangent is 1, what angle would that be?
45.
It would be 45 degrees, right? Because 1 is the same as 1 over 1, true? The rise is 1, the run is 1. Up 1 to the right 1, up 1 to the right 1. So it's 45 degrees.
Yeah.
Cool.
Okay. So the normal then would be like this. This has to be 90 degrees to the tangent. What would this gradient be?
-1.
-1. Okay, so this is an easy question. You can see that straight away. All right, so therefore, the gradient of the normal, capital N, is equal to -1. Now, do we have all the components to complete the equation of the normal now? To write an equation, we need two things. We need the slope, the gradient, and we need a coordinate. We have the gradient, we have the coordinate. So we're good to go. So here we go. We have y is equal to the gradient of the normal times by x, take away a coordinate x1 plus y1. Okay. The gradient is -1. X is 1 and y1 is 2. Expanded, negative x is equal to, y is equal to negative x plus 1 plus 2, so plus 3.
Yeah.
Okay.